Hello, this is Unit 1 review, Part 2 if you are a Carlton kid. If you're a Dudley or a Matthews kid, this is the Unit 1, or the Chapter 1 review, Part 2. First thing here, we're writing addition and subtraction equations, and these are also multiplication and division equations. So let's put multiplication and division signs here too. This is started with 1.7a. The regular price of a bike, less a $25 discount is $75. Write an equation to represent the regular price of the bike. So what we do here is we would take this $75 here and we would add the $25 to see how much the total of the bike was. So if we solve with addition, we write the equation with subtraction. So let's take the price of the bike and we would subtract the $25 discount, and that would equal the $75.50 sale price. You know, I notice I dropped the price, the dollar signs here, but that's okay. So I'll just label it. Here's the original price, orig price. Here's the discount. And this is the sale price or the new price. Okay, this next one. 20 points is 15 more than Sam scored last game. Write an equation to find the score Sam had last game. Okay, so we would go 20 minus 15, correct, to solve it. So if we solve it with subtraction, we're going to write with the opposite operation, which is plus. So let's take the points he had last game, that's what we don't know, so let's just say P, and let's add the 15 points, and here's the total of 20. So this is the total points. This is last game. And here's the 15 more this game. Alright, put some little arrows on here so we have that down pat. Alright, the total number of players on the team were separated into 6 groups. Each group had 8 players. Write an equation to find the total number of players. So we would do 6 groups times 8 players in a group, right? And again, so if we were to take these and multiply these two together, we would get the 48. So if we write it, we solve it with multiplication, we have to write this with the division. So let's think about this. Here's the total number of players. We don't know what they are. Let's call players. And we're going to divide them into 6 groups, and there are 8 players in each group. So these, let's just label these players. Each group. This would be the number of players, the number of groups. And this here, the P is the total players. Okay. 2 pairs of pants were purchased for $115. Write an equation to find out the cost of each pair of pants. Well, we would take that 115 and we divide it by 2, correct? So we solve with division. That means we're going to write with multiplication. So here's the 2 pair of pants times the cost. We don't know what it is. We'll just use C, and it equals 115. So 2 pairs. This is the cost per pair. And here's the total cost. So it works out really well. Alright. I can evaluate algebraic expression. I can evaluate algebraic expressions. So this one here, this is 1.6a video. So we're just going to substitute these in. So here's 3, and C is equal to 2. So let me put that in parentheses. Plus A, and A is equal to 3. So we just have to solve that. 3C, 3 times 2. So 3 times 2 is 6, plus 3. Plus 3 is 9. Circle out there. That was a pretty easy one to do. So now we have to change these around. We have V is equal to 8. So now we have 6, and I'll put the V. I always put it in parentheses. It'll make your life much easier. So 6V squared minus 2. Alright, so v squared. So this is really 6 times, and this is not 16, it's 8 times 8. 6 times 64 minus 2. Let's grab the calculator here. Let's do 6 times 64. 6 times 64 equals 384. Let's put an arrow up here. So this is 384 minus 2, 382 is our difference. Alright, 3b divided by 4 is b equals 12. So here's 3 and b is 12 divided by 4. Well, we could do 3 times 12. It's 36. Over 4, which is 36 divided by 4. You can put it in your calculator and it'll tell you it's 9. You can do it in your head too. So now we have 4n minus 8, or decreased by 8, and n is 3. So 4 and n is 3 minus 8. Okay, well, let's just solve this. 4 times 3 is 12 minus 8. You got 4 left there. Alright, let's move on to the next one. I can identify data in ordered pairs from a table and graph. So all of these are going to be 1.10a through 1.10b2. So there's a whole bunch of targets with these things. So, well, here's what they want to do. They want you to plug the 2 in and figure out what the y is. So we'll just take and put parentheses, just like we did before. Here's 3. 3 times 2 in parentheses minus 7. So 3 times 2 is 6. 6 minus 7, that's actually a negative 1. So our ordered pair then is 2, negative 1. We should put those in parentheses. Alright, so let's do this other one. So we've got 3, and now x is 4. 3 times 4 is 12, minus 7 is 5. So our next ordered pair is 4, 5. Alright, let's do 6. Oops. Substitute this in, minus 7. I just do these usually all at once. Substitute these in. So substitute the 6 in for x. 3 times 6 is 18. 18 minus 7 is 11. So our ordered pair is 6, 11. Okay, you can kind of see that they're going up by 6 each time. We're not sequential over here. We're skipping every other number there. So let's plug the 8 in. So 3 times 8 is 24. 24 minus 7 is going to be 17. So our ordered pair is 8 and 17. Okay, so I completed that table. So here's your x and your y's. You've got your function here, and here are your ordered pairs. Okay, let's put another one of these in. Okay, so now we've got x cubed. So I'm just going to put this minus 2. And then I'm just going to plug in the variables, 2. 2 times 2 times 2. This is not 6. It's not 2 times 3. It's 2 times 2 times 2. That's 8 minus 2 is 6. So our first ordered pair is 2, 6. Okay, now I'm going to plug the 3 in. 3 cubed, 3 times 3 is 9, times 3 is 27. So this is 327. So my next pair is 327. Now we've got 4 cubed. So that's 4 times 4 times 4, which is 64. Oops, I forgot to subtract 2 here, folks. This is 3 cubed is 27 minus 2 is 25. I'll just change that to 25. There we go. I'll rewrite it. So this is 4 cubed is 64. 64 minus 2 is 62. So the next pair is 462. And then we have 5. 5 cubed is 5 times 5 times 5 is 125. Minus 2 is 123. So this is 123. Alright, keep rolling here. Alright, find the domain and range. Well, the domain, these are going to be the x values, and the range is going to be the y values. Think of it, domain I'm getting sleepy. D comes before R, just like X comes before Y. Sometimes these are the input and the output. And no matter what, there's still an alpha order. X, Y, domain, range, input, output. So the domain, we should put these in brackets, are 4, 5, 6, and 7. The range, brackets, 12, 15, 18, and 21. Simple target, domain range. What is the domain range of this one here? Ooh, tricky. So here's the domain. Now they've run it horizontally. So the domain is 1, 2, 3, and 4. And the range is down here, 5, 7, 9, 11. All right. With these. So this is going to be the hardest of the one. We have to write some equations for these two variable equations here. Gander sells 50 hockey sticks a day. Write an equation using two variables to show the relationship between the number of hockey sticks sold, H, and D days. So what I usually do on these is I make a little XY table, because I'm really good at XY tables. So 0, 1, and 2 I'm going to use. So in 0 days, 0 hockey sticks, right? 1 day, 50 hockey sticks. 2 days, 100, and so on, right? Let's double check it. 50 hockey sticks a day. Write an equation using two variables to show the relationship between the number of hockey sticks, H, and D days. So really, my Y here is equal to 50 times the X. So now, once I got that scheduled, I just go back. So I just take them and substitute in these two variables. So if you're not sure which one, let's just try H here. Hockey sticks equals 50 times the number of days. Does that work? Total hockey sticks equals 50 hockey sticks times the number of days. Yeah. If you're not sure, label it. This would be the total hockey sticks. And here's 50 times number of days. Sounds good. Alright, do the same thing here. I always start with that little XY table. Camden runs the same number of miles each day for 5 days a week. Write an equation using two variables to show the relationship between the total number of miles he runs and the number of miles he runs each day. Well, on an XY chart, I always start with 0, 1, and 2 as my X variables. So think about that. 0 days, how many miles? Okay, so this is going to be 0 and 0. With 1, it would be 1 times 5 is 5, and 2 times 5 is 10. So what we've got here is we've got the Y is equal to 5x. Now we just have to plug the variables in. So Y would be the total number of miles, the total, is equal to 5 miles times the number of days. Okay, here's the final target. This is completing function tables. This is started 1.10c, but so we're looking at this table on the x's. We've got 3, 4, 5, and 6. Now this is the same table as 3, 4, 5, 6. Just laid it in its side. Here's the x and here's the y. We've got 9, 12, 15. And we're looking for this one. So how are we getting from 3 to 9, from 4 to 12, from 5 to 15, from 6 to whatever? Well, this table is times 3, so you just think about it. This is times 3, times 3, times 3. So 6 times 3 would be 18 to complete this table. Alright, this one, we're going from 1 to 5, from 2 to 7, from 3 to 9. So how are we doing that? Well, let's think about it. What if we took a times 5? 1 times 5. 1 times 5 is 5. But 2 times 5 is not 7. So that's not going to work. What if we took 1 times 3? 1 times 3 is 3. Plus 2 would be 5. So let's try this one. 2 times 3 is 6. Plus 2 is 8. So it's not that. So we're just going to kind of keep working through these ones here. How about if we took 1 times 2, 1 times 2, and we added 3. That would be 5. So let's try this one. 2 times 2 plus 3. 2 times 2 is 4 plus 3 is 7. Let's try that worked pretty good. How about 3 times 2? So this would be times 2 plus 3. 3 times 2 is 6 plus 3 is 9. It looks like we've got it here. So 4 times 2 is 8 plus 3 is 11. And that kind of fits our pattern. Look at it. 5, 7, 9, 11. So our rule there was the y was equal to times 2 plus 3. We would write that 2x plus 3. But we still figured that out. Okay, all right, and this table here, we got 1 to 5, 2, 7, 3 to 9, 4 to what? Now, so we'll write a two-variable equation derivative. So this is that same table from up above, right? 1, 2, 3, 4, 5, 7, 9. We've already figured this out. We've already figured that out, that the y is equal to 2 times whatever x is plus the 3. So if we had 5 down here, we would just take 5 times 2 plus 3. This would be 5 times 2 is 10 plus 3 is 13. Remember, this one here was already 11. All right, we're going to write an equation for the following. So I'll write this down here. Y is equal to 2x plus 3. Here's my equation. All right, and this one. We've got, let's see, box stuff like this. I like it a little bit better. So we've got 3, 4, 5, and 6. We've got 9, 12, 15, and we're not sure what this one's going to be. So, looks like it might be the same table from up above. 3, 4, 5, 6, 9, 12, 15. We already kind of figured this out, that this was times 3, right? Times 3, times 3, times 3, times 3 is going to be 18. So this one here, the y is equal to whatever the x is times 3. Okay? Notice how I actually made a little xy chart like that. I turned it back over and went this way. I think it's easy for kids to understand. All right, thanks so much for listening. Good luck in the testimony.